In our review of quadratic functions, we talked about having them in general form, like this problem, or in standard graphing form. And then we also studied parabolas as conic sections. And the only time you had to worry about finding the vertex and, the focus and the directrix using 1 over 4p, the only time you need to do that is if it's asking you for a focus as a conic section. In general, we did a lot more time studying parabolas as functions, which is what we're doing here in question 6. So what do we know? This first coefficient tells us whether it opens up, down, left, or right. Because x is squared, we know this is an up or down parabola. And since a is positive, we know this opens up. Remember that this value of a also tells us that the y-coordinates grow twice as fast. So we would say that it gets narrower, which what we mean by that is it gets tall faster. For our vertex, we use the formula the opposite of b over 2a for the x-coordinate when it's given in general form. So here we would take the opposite of negative 8 divided by 2 times a, which is 2. And of course, you don't have to show that on paper. So 8 divided by 4. So our x-coordinate of our vertex is 2. And then we find the y-coordinate by plugging that value into the x value. So we go to the original function and we put 2 in for x, and our first term would become 2 times 4, or 8, minus 16 would be a negative 8, plus 1 would be a negative 7 for our vertex. So we could start graphing right away. We know that our vertex is at positive 2, negative 7. I didn't make those very even, but I think you'll understand here. And we know our parabola opens up. Another helpful thing for our graphing is to look at the y-intercept. Notice when we let x be 0 that this value of c is our y-intercept. So that's how narrow this parabola is, that we know it doesn't cross the axis until we get up here to 1. Doesn't cross the axis of the y. Here the axis of symmetry goes through the vertex. So our axis has an equation x equals positive 2. The domain of our parabola, it gets wide infinitely at the top. So if we squashed it onto the x-axis, do you believe it's going to go to negative infinity and positive infinity? And we never do square brackets on those because you can never reach infinity. And the range of our parabola, so our parabola, if we moved it onto, squashed it onto the y-axis, can you see that it rises infinitely? But it doesn't have any y-coordinates below negative 7. So for our range, we would start at negative 7 inclusive, so square bracket, and it would go up to positive infinity with an open bracket. So remember that the square bracket means a closed endpoint, and the parenthesis means an open endpoint. And that's true whenever you do interval notation. All right, our next quadratic function has y squared rather than x. So we cannot say that that y is a function of x. Here, x is a function of y. So this parabola would pass the horizontal line test, but it would fail the vertical line test. So it is a reverse of what we usually studied. So here, x depends on y. So we have to make sure we reverse our thinking about the x and the y coordinates. Our value of a is negative 1/2, so we know it opens to the negative side, and it's a left-right parabola, so the negative direction would be to the left. Because it's a 1/2 value, the y-coordinates are going to grow slower, so we would say that it's going to look wider near its vertex because the y's grow more slowly. this is called standard graphing form, and we think of this in terms of our transformation. So if you think about our basic sideways parabola would be x equals y squared, and you know that would look like this parabola. So normally we would pick 0 and 0 for our vertex. So think what our transformations are going to do here. So here we're going to have to choose -3 for our y coordinate, since that has to transform in the opposite direction. And this +2 is actually going to be associated with the x. So make sure you don't do those in the reverse order. So now we know what our parabola, or where it's located at least, 2, -3. And we know it opens to the left and it's a little wider than usual. So we have an axis of symmetry through the vertex. So the equation of our axis of symmetry would be y equals the y coordinate of the vertex. And now we answer domain and range. Again, domain, think about all of the x coordinates. If we squashed this onto the x-axis, what would get covered up? That would be everything from -infinity, but it would stop at 2. So our domain, -infinity at 2, and 2 has a closed circle, so it would get a square bracket. And here our range. If you think about the y coordinates, you can see this is going to rise infinitely and it's going to fall infinitely. So that would be all real numbers, or you can write -infinity to +infinity. All right, what's the most efficient way you can explain that there are no x-intercepts of this parabola? Are there other ways to recognize this? Well, I notice that x is squared, so it's a vertical parabola. And since a is equal to 1, so since a is equal to 1 here, we know that this parabola opens up. And we could find its vertex. Sorry, our tablet's doing a little jumping here. If we found its vertex, that would be the opposite of b, would be a -1 over 2 times a. So its x-coordinate of its vertex is at -1/2. And if we plug that in, we'll have 1/4 minus 1/2 plus 10. So I think we're somewhere here like 9 3/4. But in any case, we know that the y-coordinate of our vertex is above the axis. So think what you just determined. The vertex is already above the x-axis and the parabola opens up. So is that an easy way to explain that it's never going to cross the x-axis? So that would be one explanation. A second explanation that you learned is that you could use the discriminant from the quadratic formula. The discriminant is this value, b squared minus 4ac. So if it has a negative discriminant, then we know that it has only complex zeros. And the zeros, or the roots, are the x-intercepts. So if we found b squared, in this case, 1, so we would put 1 in for b, and a and c are 1 and 10. Sorry, I shouldn't try moving. I'm messing up our video here. It's a sign that I'm overwhelming my tablet a little bit, but I think you can see here that we've got 1 minus 40, so we would have a negative number under the square root sign, so we have only complex zeros. So that means, in other words, that there are no x-intercepts. So there's 2 different ways that you could explain how a parabola might have no x-intercepts. If its vertex is above the axis and it opens up, or if its vertex is below the axis and it opens down. All right, and then let's do a application problem here. The typical application of a parabola is a vertical motion problem. So we fire the projectile straight up, so it comes straight down. So its path is straight line up straight ray up and then back down. But when we graph it as a function of time, as time goes on, our height here looks like a parabola. So S of t is the height in feet. How high is the parabola at time t in seconds? So our question of what is the height after 5 seconds, we don't know whether that's the vertex. Don't assume that. So we simply want to plug 5 in for the time. And you can grab a calculator to do this. So this is going to be a 25. And I know that 25 times 16, think of 16 quarters, will be negative 400 plus 2,000. So I don't really need a calculator. So we would get 1,600 feet if my arithmetic is correct. What is the maximum height achieved? Well, I would wonder about the vertex of this parabola. But remember not to stop with the x-coordinate. I have to do the x-coordinate first. Negative b would be negative 400 over 2 times a would be negative 32. So the x-coordinate of our vertex, if I do some division here, would be positive 180. Looks like what, 12.5 seconds. That's when. So remember the x-coordinate is in seconds. That's when it reaches its vertex. The question here is what's the maximum height? So now what do I do to answer the question? I have to find out what is s at 12.5. So put 12.5 into that variable t, and I'm going to pause the video for a second and get that answer on my calculator. And I came up with 2,500 feet. So now I know that's the y-coordinate of the vertex. So remember, looking at your graph, always make sure you understand your coordinates. The time at which it reaches the maximum height is 12.5 seconds, but the actual maximum height is the y-coordinate. So keep in mind this is in seconds and this is in feet. And part C says, when does the projectile hit the ground again? And I think we did this in class already, so think what you guys told me. You said, well, if it reaches its maximum at 12.5, there's the use of an axis of symmetry. If this parabola has symmetry, then we could just double that to see on our graph that it's going to hit the ground after 25 seconds. So if you were short of time, you could simply answer the question that way. If you wanted to do a double check, you would say, well, let's find out when is the height equal to 0. And here's your algebraic solution. When is the height equal to 0? So a polynomial equal to 0, we would factor the GCF. And we've seen this already. This is 25. And we would use our zero product property. Either the first factor is equal to 0, and that would be letting t equal 0, or this factor is equal to 0. So we knew the projectile had a height of 0 at the beginning of the problem. It was at ground level when it was fired, and now we know it reaches ground level again after 25 seconds.